say welcome. We're going to start the webinar in 1 more minute. We'll just let the last few people sign in and then we'll be starting at the hour. Thank you. Okay, so I think we'll kick off. Welcome to everybody who signed in to Picterra's webinar today on 3 ways the geospatial AI industry is reshaping the paving industry. So thanks to everyone who signed in. I'd like to introduce both myself and my colleague Patrick here, who's online joining us from the US. So my name is Caroline Bailey. I am the Senior Account Executive of Picterra. I'm based in Switzerland, where Picterra has its headquarters. I have a background in civil engineering and spent the last 5 to 6 years now working in the drone and remote sensing industry, out of Europe, but basically working globally. And may I introduce Patrick Kinsella. Patrick is the owner and founder of Elevated Solutions, and is kind enough to join us on this webinar to tell us how he's been using drones and AI in the paving industry. Patrick, would you like to introduce yourself a little bit?
Definitely. Thanks, Caroline. My name is Patrick Kinsella. I'm the founder of Elevated Solutions. We're based out of Sarasota, Florida, and we are specializing in building models for AI assessment in the asphalt industry. Currently, I have over 15 years starting out as a laborer, working my way through an operator, foreman, all my way up through estimator, and just always wanted a better way to do things.
Thanks, Patrick. Well, thanks for joining us. And may I just say how much I like your background decor? It's definitely setting the mood for the webinar today. I think everyone can appreciate that.
Well, it's not often that I have so many people in the room, so anything to calm myself down is probably a good idea.
Yeah, great stuff. Okay, well, what we're going to be talking about today is here on this agenda. So a little bit about us, which you just heard personally, but I will introduce Picterra in a bit more detail too. We'll go on to have a discussion about the geospatial intelligence that's being used in the paving industry today and why. And then we're going to go on to Patrick, so I'll hand over the screen at that point, and Patrick will lead us through some examples of real-life cases in which he's used drone imagery and AI to do his job. Then at the end, there's going to be a QA session. So at any point during this, this webinar, you can write in the chat bar down the side if you have any questions, and we'll come back and address those at the end. Great, so let's get started. Picterra is an AI platform that's based out of Lausanne in Switzerland. So we are the manufacturers of AI software. We've been doing so for the past 5 years. So founded in 2016 and based out of EPFL University, where one of our co-founders is a researcher. So very much Swiss engineering from the source here. We're a team of 17 members, half of which are developers. So this is a highly technical solution, which has been a long time in development. And we're really proud of how it works. We're getting great results in general. Many of our clients are listed along the bottom here, well, a few of the main ones, which cover various different industries. So we have quite a focus on obviously the paving industry, which we'll talk about today, but infrastructure maintenance projects in general. So that could be rail surveys, encroachment, vegetation on power lines or roads, as well as oil and gas pipeline integrity and road and general paving condition assessments, which of course is what we're going to be talking about in detail today. So why everyone's tuned in? The 3 ways the geospatial AI is reshaping the paving industry. So we have the paving industry. Overall, the main aspects of this industry are involved in a substance which is constantly subjected to wear and tear. It needs to be maintained, and plans need to be made to maintain it and maintain an asset overall in the most cost-effective and fast way. So coupled with new technologies, which we're seeing today, such as drones and AI, this gives us a record of what's happening and allows a person to record what's happening on a much more regular basis than when it was ever possible before. Using AI, the different types of damages like cracks, potholes, warping can be categorized and classified in a standardized way, which overall leads a person to be able to extract business critical insights. So the top three things that we're pulling out of this combined workflow are improved working conditions. So people on the ground don't need to be subjected to weather and potentially dangerous environments for so long, because it's much quicker to do assessments. There's a reduced situational impact, so you don't have to close down a parking lot or a road or a bridge for so long to be able to do an assessment now. And overall, it's leading to faster, accurate, and more scalable reports. So this allows a company to be able to do way more reports in a standardized way than was ever possible before, which frees up your time to do other tasks, which is what we all want. All right, so let's go on to seeing this in practice. Here's just a couple of examples of what it looks like to extract cracks using AI. I'm going to hand over to Patrick at this point to talk about some of his real life examples in more detail. So Patrick, I'm going to let you share your screen and start talking through some of the examples that you've done in real life. Maybe you could just refresh our memories. How did you get started in this industry, and what was it attracted you to trying out drones and AI? Because it's obviously quite new technology just in the last 5 years.
Definitely. So, you know, I'm a pretty lazy guy is how I always like to put it. And when I started, you know, doing real estimates projects, you know, you're starting to walk for several hours, and you know, it just seems like you're always missing something and going back. And it just seemed like in today's day and age, when everybody has a pocket computer in their pocket, like there's better ways to do it. So I started looking out, and LinkedIn obviously is great for this, but I hopped on and I found drones and photogrammetry software, and giving the ability to, you know, rapidly create a 3D model and an image that I could go home later and do my annotations manually. And that was great. That was huge. It was a big improvement on my workflow. But again, you're spending hours clicking buttons. And again, just like what AI is solving, we're clicking a different pixel every time because we're people, we're individuals. So I thought there'd have to be a better way to be able to identify all the defects with all the computer vision out these days. And I started searching around, and that's where I found Picterra. And they were very much into the geospatial satellites, and I started asking questions. What about, you know, images closer to Earth? They said, give it a whirl. And so now you're starting to see the fruits of give it a whirl. So I started trying to take my expertise and teach a computer how to assess a piece of property the way that I do. And so that's where, you know, just because we only have limited time, and I'm a very long-winded person, I'm going to bring up now some screenshots of just some of the detectors that we've made and talk quickly about them. But you know, this is reduced, you know, from spending several hours, 4 or 5 hours manually annotating all of these things with drones and drone deploy and Pix4D. We were able to cut that down to about 20 to 30 minutes, depending on the complexity of your models. And it's just something that's really been a time saver for me. It's been huge. Caroline, I'm trying to share the screen, but I believe you're still sharing.
Oh, okay, I will stop sharing.
And I don't know if it's me or not. As everybody will know, I'm not necessarily the most tech savvy person.
How's it now?
Let's see, it should be coming up there now. Let's see.
Yeah.
Are you seeing it?
Started screen sharing, yes.
Are
Okay.
you seeing
Perfect.
my asphalt detection?
I am.
Awesome. So this is, hold on one second. I still need to learn how to do this. So this is some of the detection and the models that we've built. Asphalt detection, concrete detection, things of that nature, so that we can, number one, create the data that we want to capture so we know how much asphalt is in there, as well as so that we can then refine where we process our models so that we continue to speed things up and make them more efficient.
So I'm just checking here. What you've uploaded is an orthomosaic, so a combination of drone images that you took of a parking lot, and you've uploaded those to Picterra, and now you're going to be using Picterra as an AI platform tool to find different types of materials first, and then find the damages within those areas.
Correct. Our clients will fly the maps themselves, and then they will send us a stitched ortho that we upload to Picterra, and then we are able to process all of our models in a very rapid fashion, and a lot better and clearer than I'm going to do using a wheel on the ground. Things like sidewalk detection, we can even go ahead and take this a step further and tell you how many broken pieces of sidewalk you have versus correct pieces of sidewalk. We have curb and gutter, not just the typical standard curb and gutter that you see, but we also will have monolithic curb. And what I like about this the most is, you know, we're able to train that it's not just detecting a surface of concrete here. It's actually noticing all the things that make this monolithic piece of curb different than this concrete base pan here, different than this concrete curb here, and different than the steps over here. And that's one of the things that I really love about playing around and continuing to train on here. And then we get into pavement markings. Just to be quick, we just did a quick sample here, but we can do any color. We can go ahead and identify how many arrows you have versus handicap stalls, things like truncated domes. We can do a lot of asset detection as far as bollards, drains, manholes, water valves. It kind of, if you can see it, you can be, Picterra can be trained to detect it. And it's, the power that you get here is amazing, and not saving the least, but the biggest thing here is the crack detection. This right here is just a general crack model here to illustrate just how it doesn't read the concrete cracks here. It doesn't read into any of the bushes here. It is only reading the asphalt because we train out the concrete so that we can have a concrete detector as well. So it's just, we do alligator cracking, edge, block cracking, the list kind of just, it goes on and on for whatever the customer needs. You know, it's something that can be very tailor-made.
So you mentioned quite a lot of different aspects or different objects that you found there. Is that what you'd say is a main advantage to you for using Picterra? The fact that it's not just for the cracks, not just for the material itself, but it's other things like street furniture, curbs, things you might find around the parking lot as well?
Exactly. It's really almost an asset identification tool. The sky is the limit. It's really limited by your creativity. As weird as this is, you know, back when the pandemic just hit, I took a picture at a local grocery store, and I just was detecting toilet paper and paper towels, you know, just to make a joke of it. But what it really demonstrates is, you know, we could detect all the blue cars in a lot versus white cars, and that's what gets really exciting. Is your drone has already made a model of all of these objects inside of your map, and it's really, how many of them do you want to detect?
I think people might be wondering, yes, I have a drone and yes, I'm making models. So I make 2D models and 3D models. Do you want to just tell people what the workflow is here to get the input data into Picterra?
Definitely. So with our models, we went ahead and we had to play around quite a bit with altitude. So we found out after lots of testing, the best altitude, we're flying at about 100 feet. Most of our training data has just been captured off of Mavic 2 Pro, nothing super fancy. But we would make a 2D model on drone deploy. Once it was stitched together, we would upload it to Picterra, and then we would go ahead and create a detection area to make sure we're only assessing what we need. And we would work down the list of all the things that we were trying to report, and we'd hit one model after a time, and each model taking 7 to 10 minutes to process and working our way through. This is alligator crack detection. I wanted to bring this up because if you look closely, this is more of a model that we have models that can go and measure every single one of these cracks. And that looks pretty, but that's not necessarily, what we're after. Picterra gives you the ability to read a defect the way you want it to be read. So what we're finding here is the area of what material would need to be replaced as opposed to just the area of the crack. So with this, we can go ahead and turn this into a square formation and actually get our quantities for patching based off of this. Things such as crack fill. Most of these cracks here are all filled with crack fill already, which is surprisingly was actually something very difficult to train out at first. We were registering all cracks and things of that nature, but with a little bit of playing around, we were able to get this going, and we're able to deploy these models on an 80-acre piece of property, and know that it's going to be accurate all the way across. And then we can deploy the same models across the entire portfolio, knowing they're going to be reading that measuring tape the same exact time, the same exact way each time.
I think that is a key point, actually. So you're making these models which you've made yourself, and you didn't need to be a machine learning expert or something to make them. And then once they're made, you can deploy them across all of the sites that you're gathering information from. So it's a really scalable way to pull out these, like the cracks or the reparations here, in a standardized way. Would you agree with that?
Definitely. That's really the benefit that we're seeing is the standardization and the time savings. If you don't have a standard way that you're assessing, if that measuring tape's not being read the same time each time, your numbers across the portfolio are inaccurate, and so is then your budget. It's time to take a step forward and really let the computers, do a lot of the heavy lifting for us and give us the ability to do more with less work. I will end my slideshow so that you can pick it up there if I know how. Okay.
Great. Let me share my screen again, and I will go back to my slides. Okay, wonderful. Yeah, back on my slides. Can you see that fine, Patrick?
I can see your slides.
Brilliant. Okay. So yeah, I think we've come to the question and answer session. So I know there were quite a few questions that came up over the course of this. I think just to summarize what's been shown here, in case it clears up anyone's questions up front, the workflow is to fly drones, in this case, to get imagery, which shows the things that you want to find. So the cracks quite clearly. Patrick used drone deploy to make 2D orthomosaics, but we're agnostic to other photogrammetric softwares out there. So we have no specific affiliation at this point. Those are uploaded as the input data. the models have been created and then can be run across every orthomosaic that's uploaded to pull out the information required in a standardized way across huge areas, which is the point of AI. So to stop a human being having to outline every crack, either counting them or outlining them, so that it can be done instead for you. So yeah, that's the overall workflow. And thanks, Patrick, for showing us some of your examples here. So I'm going to go on to look at some messages. Okay, so one of the questions that's popping up quite a lot is, can you use data from a vehicle-mounted LiDAR system or generally 3D information in general? So the answer is no. The input data is 2D, either 2D images or 2D orthomosaics that are pointing directly down at the ground. So that's the way the system is set up for you to be able to use our platform. It has a user interface built in, and it's aimed with the angle looking directly down at the ground. So that's the best way to get started. I mean, if you have cases, I think our tech team are always willing to talk them through with you, but that's the main setup at this point. Okay. How many training images of a specific object do you need? That really depends on the object itself, but I mean, it depends how regular an object is. So if it's very regular, then you need fewer examples when you're training a model. So upwards of 20 to 50 examples, something like that. If it's a more varied object, then you just need to keep giving it more information. So probably more than 50, more than 100, something like that. But once you've made a model, then it's made. You can keep using it over any sites in the future. You can keep improving it too, but at least it's going to be standard to the level that you've made it and tested its accuracy. Would it be possible to use 360-degree imagery at street level? So that's kind of what I was saying before. If you can create a 2D image from a 360-degree image, then yes, you would be able to use that as input data. But what's really important is that every image that you use, because you're training models on images at a certain angle, so every image you use in the future should be at the same angle. That's why looking from above straight down is very reliable, because it's always at 90 degrees to the ground. So you're training the software to find things that always look the same. The angles are always the same. Which model will give you the best fit and accuracy? Well, that depends on the object you're trying to find. I think, like I said before, objects that are very standardized will typically be found with higher rates of accuracy, but it depends on how you build the model, how you draw the annotations, like how accurately, and how many pieces of input data you give, how varied the object is, like if the light is different, if the object you're looking at is on different surfaces every time, that's background information, which the AI will pick up on as well. So what tools do you offer? Polygon bounding boxes for labeling training data and things. So yes, you are able to draw polygons by hand or mark things as points. You're also able to upload data if you've already done that in some other file and it exists. We don't want you to have to do it all over again. So you'd be able to upload annotations you've done elsewhere to use as training data. You can also set boxes or set areas in which you want to find annotations, so you don't have to run a model over huge amounts of data where you're not interested in the results. There are no cracks or something because it's buildings in this case. So you could outline the polygons of parking lot and just find the cracks in those areas. Okay, can you get location data for the defects? Yeah, so, I mean, Patrick, do you want to comment on this? I'm just reading out some of the questions. Why don't you tell us what you think?
Definitely. I think I'm also trying to answer to everybody too in the chat a little bit. I don't type the fastest, but yeah, no, location data. So what each one of these defects that you viewed today, that comes with, lat and longitude coordinates. It comes with the perimeter, and it also comes with your area. So it's very data rich. And, some of when we run a crack detection on a mile of road, we can detect up to 15,000 individually annotated cracks. It's a very robust system, and it's very powerful. I see another one. How long does it take to process data using AI? And I was writing to you right away, but I'll just answer it here. It really depends on the complexity of the model and the defect that you're trying to find. If you're looking for something that's simple, water valves, manholes, something that's going to be the same every single time you go to look at it, you're going to get very, very fast processing times. Now, when we run some of our really hardcore crack detection on, say, 80 acres, now that's still only taken 15 minutes, and that's over an 80-acre piece of property, rendering all of those, data sets for you.
I'm looking at this other question about the locations. So I think it's important to say that when you use drones to get images and then create orthomosaics, these days most drone images are georeferenced, which means that the orthomosaics are too, which means that any results that you get from Picterra are also georeferenced. So if you're outlining cracks or outlining cars or something like that, you will end up with various raw data outputs like shape files. That's the kind of thing Patrick was showing today. Those shape files will be geo-referenced as well, meaning you could output them into ArcGIS or some other GIS software and be able to pair them up with other layers over the same area.
And it also goes that, when presenting to a client, when you do offload this to ArcGIS, Google Earth, things of that nature, you're able to overlay it onto the ortho that you've put in there as well. And you're able to see all of the distresses at once. For simplicity's sake, we showed you one distress at a time because it can get quite overwhelming seeing, 30 different things annotated so colorfully. But yeah, it really works really well into other workflows. And yeah, I'm gonna let Caroline keep answering the questions though.
Sure. You're not gonna get off so easily. I'm gonna come back to you.
Come on.
As far as payloads and cameras, which ones would be needed? So I think this is actually a really key one, isn't it? So what equipment do you need to get the images in the first place that will be good enough to see very small things such as cracks? Let's not forget that they're very small, some of them, like millimeters in diameter. So you will need a camera that's high enough resolution from drone images to be able to see these things. If you can't see them, if they're not clear in the images, then first you won't be able to train the AI to find them. And second, if you did, you wouldn't, like when you ran the model and deployed it, it wouldn't be able to pick up the cracks. So it's really important that you use a consistent resolution of imagery to both train models and deploy models. So that said, I mean, to find cracks, you know better than me, Patrick, but I'd say less than 1 centimeter GSD to be able to find small cracks, and probably a bit larger, maybe up to 2 or 5 centimeters for potholes and things like that.
So what we found was we used the Mavic 2 Pro, the DJI Mavic 2 Pro, shoots with a 20 megapixel camera. We maxed our overlap front and side, and we flew at 100 feet. And that would get our resolutions down to about 0.4 to 0.5 centimeters when we were looking at it. So our pixels when we are at full zoom are about 1/4 inch. So that gives us the ability to, the goal for us was not just to detect that a crack was there, but to be able to quantify that crack. So we wanted to get clear edges. And at that altitude, we've found the best results for getting almost just a singular pixel edge going through. We've had people use a Mavic Air, and I've processed data on it, and it worked. It was fine, but it's the age-old good data in is you need to have good data in to get good data out. So that's where I recommend 100 feet. But if someone is looking for a very macro image of something, you can fly at 200 feet, and maybe you're just looking for a quick condition and you're not worried about creating a scope of work or an ITB or something of that nature. It can be very tailor-made to work well within the workflow your company currently has. And that's why it worked so well for us, is we didn't have to make any big changes to make it work. And I am not a software person. I was born with a shovel in my hand in this industry, and I put together AI models, which is a laughing matter to me when I get off the webinar. But it goes to say the power of Picterra and, you know, some time put into it.
Absolutely. Thanks, Patrick. I'm just checking you can hear me because I think I fell off the internet connection there. Is everything fine with how you can hear me?
I can hear you just fine.
Perfectly. Okay. It's live theatre, folks. You never know quite what's going to happen. Okay. So I think we've covered most of the questions I can see coming in here. There are some repeats of questions, so sorry if we have missed out something that you asked specifically. Oh yeah, here's a good question. Is this online or is this downloadable on your own computer? So this is a cloud platform, that's true. So you would upload images to the Picterra platform, you'd create your own account, make all of your models to find different objects or different types of cracks online, and then be able to run those models across your images also online. So it's all hosted on our cloud. Yeah, so that's the way it's working. Okay, do you have any final comments here, Patrick? I'm thinking probably tie things up at this stage, and we'll go through all the questions and make sure everyone's questions are answered and email you personally after this if yours wasn't answered well today. Do you have any final remarks on everything we've discussed?
Really, nothing too big. It's really just the big thing for me is the standardization across a portfolio. That and how much time it saves. It's getting people out of the roads. You don't have to change, you don't have to drive in a road. You don't have to stand in any more live traffic to put some marks in the ground or to measure a crack or a pothole anymore. I see this as moving everything in the right direction, and I'm just excited to have found it so already.
That's great. And I'd like to thank everybody for joining. I think there's many conversations we could have just based off the questions that have come in today. So our contact details are on the slides and on the video, which this is being recorded, so we'll be sending it out to everybody tomorrow. And in case you didn't see this live, I guess you're watching it right now. So we'll be sending that out. My details are at Picterra, Patrick's are at Think Elevated, and we'll both be happy to get back to you and continue the conversation. So do add us on LinkedIn. We'll be updating and publishing more as more and more results come out. And we'll be really happy to talk to you about your specific projects. So thank you very much, everybody, for joining, especially Patrick. I wish you a very nice rest of the day.
Thank you for having me, Caroline. And thank you, everybody, for listening to me, just rant over here.
No, it's great. I mean, having somebody that's a real user that's been in the field, boots on the ground, it makes all the difference hearing how you got used to this in reality. So thank you so much. And thanks to everyone who's commented. Great to see so much participation today. Getting some nice comments of thanks right now. I appreciate that. Okay, thank you, everybody. Have a great day. Bye-bye.
Bye.